So today is lesson 3.5. We're going to be looking at using the distributive property to help us solve some equations. So it's going to be very similar to everything we've done. It's kind of combining two different sections that we've already done. We're going to talk about the distributive property, which we know very well, and then also solving equations, which we've covered now for a couple sections in a row. So the big idea today is that by collecting like terms, which we know have the same variable with the same exponent, or expanding expressions, which is using the distributive property, get rid of parentheses and so forth, you can transform many equations into the form ax plus b equals c. And this is the standard form that we like, two-step equation where we can subtract b and then divide by a, and we have our answer because x is now alone. So no vocabulary words here. We're going to be doing a lot of the same work, just kind of combining some things into one. So we're going to solve and check these. So if you take a look at this first equation, looks a little bit different because we have more than one variable. It's the same variable though, okay, and it has the same exponent. So we consider this a like term. So anytime you see multiple variables on the same side of your equal sign, you can just go ahead and you can put them together. So we're going to simplify this whole side. We've got 9y minus a 1y. So that's going to be 8y. We're going to leave the right side alone. And now by that simple step of combining like terms, we've got a very simple equation set up to solve. So 8 times something is 40. We're just going to divide by 8 to clear it out. And so y equals 5. Now it did say to check. So we're going to run a quick little check. Go back, rewrite the original, plug in our answer that we think it is. So 9 times 5 minus 5 equals 40. So 45 minus 5 equals 40. 40 equals 40. The check works. So our answer of y equals 5 is good. So combine like terms on the same side of the equal sign if possible. If you do have a variable on either side of the equal sign, you can't just put it together. Now that's for another day. We're not going to cover that today. But we wouldn't be able to just combine the 9y and the minus y if they were on separate sides of the equal sign. So it's only when they are on the same side, combined in the same expression. So moving on now to the second example. And this one we can't combine like terms right now, but what we can do is expand the expression using the distributive property. Okay, so we're going to multiply. We're going to get 2x plus 6 equals 7. Okay, we're going to minus 6 on both sides. And you may start looking at this and be like, well, I think I made a mistake because this isn't going to divide nicely, but that's okay. Not everything always does. Divide by 2. So x equals 1 divided by 2, which is 1/2, which we could write as 0.5. Now we'll go back and check this in a second, but I want to run this equation a different way. It's important to know that most equations have multiple ways of attacking them. You don't have to solve it one certain set of ways. So if you look at this, we could clear out the 2. So right now I have two things being multiplied. The 2 and the whole quantity x plus 3. If you think about if we knew what x was, we could add it to 3, and this whole quantity inside parentheses represents one number. It's being multiplied by 2 to give you 7. So since these are two things being multiplied, if I want to clear one of them out, I'm allowed to divide by them. Okay, and that's going to clear out the 2. So I'm left with x plus 3. 7 divided by 2 is 3.5. And if I minus 3 now, so that x is by itself, 3.5 minus 3 is 0.5. The same answer I got here and here. So let's run a quick check. Back to the original. 2 times 0.5 plus 3 equals 7. You got to follow your order of operations in a check. So technically you're allowed to distribute, but you might as well just combine inside your parentheses. So that's going to be 3.5. And if you do 2 times 3.5, you get 7. All right, so two different ways to attack that type of problem. If you want to clear out the front, you can. Again, this is multiplication of two quantities, so you can divide and get rid of it. Or go ahead and use your distributive property and create an equation that's in that nice ax plus b equals c form, and then we know how to solve it from there. All right, sliding down now. We're going to do the same work, a little bit more involved, and we've got decimals, which sometimes can look a little scary. So let's just tackle this, and I'll show you that this is not that big a deal. So first of all, always find your equal sign. It's going to divide your problem. So I don't have anything to do on the right. I want to simplify the left side. If I can get this down into that ax plus b equals C form, I'm in good shape because we all know how to solve these two-step equations. So I've already got C, but I've got a little bit going on over here. So if I was just given this and I told you to simplify it, I hope all of you would start distributing. We're going to leave the 29.95 alone, but we're going to distribute the 0.6 to get this out of parentheses. That'll create 3 terms total on the left side, 29.95, the product here and the product here. All right, and then we're going to combine anything that's a like term. So we're just multiplying 0.6 times m. So that's 0.6m. Notice that I dropped the zeros. You can keep them, but 0.6 is the same as 0.60. So 0.6m minus, and now you got to do 0.6 times 50. Okay, just grab your calculator, and that'll give you 30. It's kind of like 60%, 0.6. 60% of 50 is 30. If you think about 60 is out of 100. So 60% of 100 is like 30 out of 50. It's half. All right, now we're going to combine some like terms over here. The m is going to stay by itself. It does not have another like term, but I can combine the whole numbers. So it's 29.95 and a minus 30. Those are opposites, right? We have a positive and a negative. They're going to cancel each other out. So we just need to find the difference between the two. Got more negatives. So it's going to be a minus. And the difference between those two numbers, if you think about it like money, $30, $29.95, it's just 5 cents, 0.05. All right, and now I have that nice ax plus b equals form. I've done all that work. Now the steps are simple. We're going to eliminate this piece, and then we're going to eliminate that one. Since this is a minus, we're going to add 0.05 to both sides, leaving us just 0.6m. Over here, when I add 0.05 to 0.15, it's like 5 cents and 15 cents, 20 cents. You can put the 0 if you want. And now all I have to do is divide by 0.6 to get rid of it. And when I divide this, I get 167. Okay, run a check. Always back to the original, not to halfway through to a simplified version of the original, because if you made a mistake in simplifying and then you check halfway through, you may not catch your mistake that you made early. So you got to go all the way back to the original to make sure you could catch any mistake that you could have made. So 29.95 plus 0.6 times. Now I'm going to jump right in here. M is 167. That was the only place that I saw an M. It's the only place I need to substitute. And now in here, I can just follow my order of operations. So I'm not going to distribute, although you can. I'm just going to follow order of operations and work inside parentheses first. So 167 minus 50 is going to be 117. All right, and I'm going to grab my calculator. I'm going to do 0.6 times 117, and that's 70.2. And before you just go ahead and say, well, that must add to that, always double check it. So put it in your calculator. Make sure you add 70.2 and 29.95, and make sure your calculator does give you that answer. It will, but don't assume, because if you're just going to write down that last line, you're not actually checking your work, because if these don't add up, it's telling you that your M is incorrect. And if you just assume it's right, then you haven't even done a check. All right, so there's some nice work there. The main difference between anything we've done so far is that we just need to distribute and combine like terms first, get it into this ax plus b form, and then run it just like we've been running it. So if you turn it over, one last question, a little bit more involved. We've got more going on here on the left side. So I basically have 2 sets of distributions that I need to do. Notice this side is already the 6. If I'm trying to get it down to ax plus b equals c form, I've already got c, it's 6. I don't know what my a and my b are yet. And obviously, this is x and this is going to be k, but that's the variable spot where the x is. So first thing I'm going to do here is distribute. So I'm going to get a 6k. I'm going to get a plus 8. You need to distribute here, and this is where most mistakes are made. That's like a -1. So when you times it times the 9, it just makes it -9, no big deal. Most people get that. The mistakes are made right here. So most people just bring down the -7, but this is a -1 times a -7. So that's going to be a positive, negative times a -7. And again, that's where big mistakes are made. All right. I think if there's going to be a mistake, that's where it's going to be. But now we need to make sure we combine like terms correctly. Starting with your variables, you have a 6 and a minus 9. So that's going to be a negative 3k. Positive 8, positive 7 is 15. Now I've got that nice ax plus b equals c form. So c is 6, b is 15, and a is negative 3. All we got to do is run the numbers now. So we're going to minus 15. You get negative 3k. You're going to do 6 minus 15, and you're going to get negative 9. Divide to eliminate, and k equals positive 3. So it does say solve and check. Let's run the check here all the way back to the original. You should rewrite the original. And now substitute in everywhere you see a k. So in this problem, we have 2 k's here. So we need to make sure we substitute in both spots. 3k means 3 times k, so 3 times 3. 9k means 9 times 3. And now one step at a time as you run through this check. So we're going to complete inside parentheses first, following order of operations. So 3 times 3 is 9. 9 times 3 is 27. Next step, follow your order of operations inside parentheses. So 9 plus 4 is 13. 27 minus 7 is 20. Right side is simplified, not touching it, right? So 2 times 13, 26 minus the 20 equals 6. So 6 equals 6. Our check works out. And so we know that k does equal 3. So we want to completely simplify the left or the right side, because I could switch this and put the equals 6 on the other side. So there's no left or right that matters here. It's just completely simplifying both sides of the equation. And right now you're only going to see one side that needs simplification. Try and get it down to that ax plus b form. And then once you're there, just run your two-step equation steps like we've been doing the past couple of days.